So hello my dear students and learners. In the series of data structures and algorithm, in my previous video I have discussed about the concept of structure in C language. Now that was a very important prerequisite in data structure. Now today we are going to discuss another important prerequisite, and the name of the topic for the day is dynamic memory allocation. Now before going to discuss this topic, please let's have a look on the board. First I am declaring an integer array A having size 5. So after executing this line by the C compiler, what will happen? The compiler will allocate memory for these 5 integer values. Okay, so suppose if you are working in a 32-bit compiler, and in 32-bit compiler integer will take 4 bytes of memory. So for 5 integer value it will take 5 4 20 bytes memory in contiguous locations. Okay, so 20 bytes memory will be reserved. Now after certain point of time during the execution of the program, during the runtime of the program, you have realized that although you have declared the array having size 5, but you need to work with 5 more elements. So you have to store these 5 elements. For that you need the space for extra 5 elements. But since you have mentioned the size of the array once, it is not going to update anymore. Okay, so you will not be able to change it. Okay, so that means whenever you are declaring an array, that means it will be a static allocation. Okay, so that is the main drawback of an array. Okay, so far we have overcome this limitation of this fixed size array, that we have declared an array with enough size, and after declaring an array with large size, if we are inserting a very few element over there into the array, then what will happen? The lots of memory space will be wastage. Similarly, if you are declaring the array with smaller size, so you cannot insert a larger amount of data. Okay, so that is the main drawback of a fixed size array. Now how can we overcome this situation so that during the execution time, during the runtime of the program, whenever the memory will be required, we can allocate it as per our requirement? And the answer is dynamic memory allocation. So what is dynamic memory allocation? Dynamic memory allocation is basically a technique. It is a method through which we can allocate memory during the execution of the program, during the runtime of the program, as per our requirement. Okay, so in C language there are 4 types of functions available. For example, malloc, calloc, realloc and free functions. So with the help of this function we will implement this mechanism called dynamic memory allocation. So at the execution time, with the help of this function we can allocate memory. Similarly, suppose after certain point of time some memories are not being used in the program, so we can also preserve this memory. Okay, so the memory will be released through the free function. Okay, so now we are going to discuss all these 4 functions one by one. Okay, so since these all 4 are system defined functions, so we have to include the respective header file. So it belongs to the header file stdliv.h. Okay, in this header file these 4 dynamic memory allocation functions are there, which we are going to explain one by one. Okay, so first we will discuss Malloc function. Okay, now what is Malloc function? A Malloc function is one of the most powerful dynamically memory allocating function which will allocate memory during the runtime in a single block. Okay, so and after allocating this memory, it will return the base address of this total allocated memory to a pointer. Okay, now we'll check what is the syntax of the malloc function. So suppose we want to allocate memory to store 5 integer values. So 5 integer means how many bytes will we have to reserve? 5 4 20 bytes. Okay, so we are doing so using the malloc function. So first we are declaring an integer pointer ptr, that means ptr is a pointer to an integer, and then we are calling the malloc function with the help of the syntax. Ptr is equals to int star, then malloc, then suppose we want to allocate memory for 5 integers, so 5 4 20 bytes. So we are passing 20 to the malloc function. So this is the syntax of the malloc function. So malloc is the function we are calling to allocate 20 bytes of memory. We are passing 20. So malloc function will allocate this 20 bytes of memory in a single block. Okay, now after allocating this memory, 20 bytes memory, suppose the memory allocation is being done like that. So this is the memory map I am drawing. Okay, so these 20 bytes will be allocated in contiguous manner, and after allocating this 20 byte of memory, malloc function, suppose the allocation is starting from 1000 to 1, and so it will end at 1020. So after allocating this 20 bytes memory, malloc function will return the address of the first byte, that is 1000 to 1, to the pointer ptr. Now what is this install? So malloc function actually returns a void pointer. Okay, void pointers mean this pointer can be assigned to any other pointer. Now we want to store the base address 1000 to 1 to the pointer ptr. Now what type of pointer ptr is? Ptr is an integer pointer. So we are not going to assign the void pointer to the integer pointer. So before inserting this pointer, assigning this address to the pointer ptr, we are changing the type of the pointer from void star to int star. Okay, that means we are casting the type. So this is actually called type casting. Okay, that means the void pointer that malloc function is actually returning will be converted to integer pointer, and then the starting address 1000 to 1 will be assigned to the pointer ptr. That means ptr will now point to this location 1000 to 1. Now using this pointer we can access each and every location, we can assign value, we can retrieve value. Okay, so malloc function will allocate memory in a single block. Now here the 20 bytes have been reserved for what purpose? To allocate memory for 5 integers. Now we can also mention this 20 bytes like that. ptr is equals to int star, then we are calling the malloc function, but instead of writing 5, what we are writing? 5 multiplied by size of integer. Okay, now size of integer is what? Size of integer is 4. Okay, so 5 for 5 integer, it will take 5 4 20 bytes. Okay, so as a whole it will take 20 bytes of memory. So same parameter we are passing, but not explicitly we are mentioning 20 bytes. Rather we are asking the compiler, you find out the size of integer and then allocate the memory for 5 such integers. So 5 multiplied by size of integer. So 20 bytes memory will be allocated. But malloc function, after allocating this 20 byte in a single block and returning the base address to the pointer ptr, it will not assign any value to this location. Okay, so this location may be filled up by some garbage value. Okay, so basically malloc function is used to allocate memory for a single dimensional array. Now for example, if you want to allocate memory for integer 5 integers in an array, so you have to write it like that. So this is called static allocation. So this is static allocation. This size cannot be changed. We cannot resize this 20 bytes, we cannot increase it or we cannot decrease it also. But if we want to do the same thing, that means you have to write this line. Okay, so this is the substitute of this line. That means it will allocate the memory for the 5 integers. So this is called dynamic allocation. Okay, now at the later stage of the program, during the execution of the program, if you want to increase it, you can also increase using another function. This is called realloc function. So the next function is called calloc, C-A-L-L-O-C. This function also belongs to the same header file stdlib.h. Now what is calloc function? Calloc function will also allocate memory during the runtime of the program, but in multiple blocks. Okay, malloc function is capable to allocate memory in a single block only, but the calloc function is capable to allocate in multiple blocks. Okay, so and not only that, after allocating this memory, calloc function will also return the address of the first byte like malloc function, and after returning the address, then it will also assign the 0 value to each and every location after allocating the memory. Okay, so what is the syntax of the calloc function? So suppose we want to create memory for a 2-dimensional array having 5 rows and 5 columns. Okay, so first we are declaring an integer pointer that we have declared earlier. So int star ptr, so ptr is a pointer to an integer. Then we are calling the calloc function like that. So int star calloc, then what you have to mention? You have to mention 2 things. That first, how many blocks you require. So first one will mention the number of blocks you want to allocate, and the next one will be the number of bytes you want to allocate in each block. So What do you want? We want to allocate 20 bytes to store 5 integer. So here 5 is the number of blocks and 20 is the number of bytes will be allocated in each block. Okay, so this is, we have already discussed, so this is called typecasting. Now this is number of blocks to be allotted, and this is the number of bytes in each block. So number of bytes to be allotted in each block. Okay, so 2 parameters we have to pass. Now this syntax we can write in some different way. For example, ptr is equals to int star, okay, then calloc, okay, then 5 into what? We want to allocate 5 blocks, so that's why 5 comma, then in each block we want to store 5 integer. So 5 4 is 20, that's why. So we will write 5 multiplied by size of integer. Okay, so ultimately it will allocate 5 comma, it will allocate 5 comma 5 multiplied by 4, that means 5 comma 20. Okay, it is same. So you can use any of this syntax. Now when this line will be executed by the compiler, now we will check what will be the corresponding memory map. Okay, so now this is the corresponding memory map of this calloc function. So suppose the allocation is starting from 2001. So each and every block, each and every row will occupy 20 bytes of memory. So it will ends at 2020, then from 21 to 40, then 41 to 60, then 61 to 80, 2080, and finally 2081 to, it will allocate to 2100. So that will be. Now after allocating this 100 bytes of memory, that means 5 blocks and each block 20 bytes, that means 520 is 100 bytes of memory will be allocated, and after allocating it will return the starting address of the first block, that is 2001, to the pointer ptr. Now calloc function also returns a void pointer, that's why this typecasting is required. Okay, so that we have done. So the first one is the number of blocks and the second one is the number of bytes to be allocated in each and every block. Okay, now after allocating this memory and returning the base address to the pointer, calloc function will assign 0 value to all these locations. Okay, so you can check all the locations has been filled up by 0. So that was not been done by the malloc function. So what is the difference between malloc function and calloc function? Malloc function usually allocates memory in a single block. So if we need to allocate memory for one dimensional array, we will call the malloc function, and calloc function is capable to allocate memory in multiple blocks. So if we need to allocate memory for 2-dimensional array, we will call the calloc function. You have to just, now next difference is that malloc function accept only one parameter, that is how many bytes you have to allocate it, because bytes will be allocated in a single block, so no need to mention the number of blocks, it will be by default 1. But in case of calloc function, you have to pass 2 parameters. First you have to mention that how many blocks you want to allocate, how many rows will be there, okay, and then you have to mention in each and every block or row how many bytes will be there. So calloc function accept 2 parameters, malloc accept 1 parameter. Okay, not only that, malloc function does not assign any initial value after allocating the memory, but calloc function will assign 0 value to each and every location. Okay, now we will check that after now this is the calloc function, we have allocated the memory for 2D array. So if we allocate the memory using the array declaration, so you have to write it like that, int a 55, that means here 5 rows will be there and 5 columns will be there. So that has exactly been done using the calloc function. But what is the difference? This is called static allocation. You cannot change the size of the memory further during the execution of the program, runtime of the program. But if you have allocated this memory using the calloc function, you can change the size of the byte. You can increase it, you can decrease it as per your requirement. So that is the difference between static allocation and dynamic allocation. Now we are going to discuss the third function, that is called realloc function. Okay, so third function is realloc function. Realloc. Now what is realloc function? From the name you can understand that realloc means reallocation. That means the memory which has been already been allotted by either calling the malloc function or calloc function, by if you want to change it further, either you can decrease the size or you can increase the size, you have to call the realloc function. So your size that you have already allotted, it can be further updated. Okay, so what is the syntax of the realloc function? So suppose we have already declared, we have already allotted some memory using the malloc function. So the same syntax I am writing. So int star ptr is equals to int star, then using malloc function, suppose you have allotted 20 bytes of memory. Okay, so after this execution of this line by the compiler, 20 bytes will be reserved, 20 bytes. Now suppose the allocation is starting from 1000 to 1, so it will insert 1020, and then base address will be returned to the, after required typecasting, the 1001, the starting address will be assigned to the pointer ptr. That means ptr is pointing to this address 1001. Okay, now we want to increase the previously allocated 20 bytes to 40 bytes. So for that purpose you have to call the realloc function. Okay, now realloc function can be called like that: ptr is equals to realloc, then ptr comma 40. Okay, check what is the syntax. We are calling the realloc function, it will accept two parameters. You have to pass the starting address, that is ptr is pointing to, that is 1001, and then comma 40, the requested bytes. So the realloc function will start allocating from the same address. The malloc or calloc function has been done. So if the previous allocation has done from 1000 to 1, so the realloc function will start from 1000 to 1. Now the size will be increased. So after executing this line, what will happen? The total number of bytes will be 40 now. This 40 bytes will be reserved. Okay, and after, so it will start from the same address, that is 1001, and now it will insert 1040. Okay, so and after allocating this memory, since it is starting from the same location, so ptr will point to this location. So that is the reallocation. Initially it was 20 bytes, now we are increasing the number of bytes from 20 to 40 by calling the realloc function. Okay, so realloc function also accept two parameters. The first one, you have to mention the base address of this previously allotted memory. From the same address, the further it will allocate the additional memory, and then you have to mention that what will be the total memory that you want to have in the final allocation, after the final allocation. So it will be 40 bytes, so we have mentioned 40. Okay, so if you have allotted the space previously by using the calloc function, so you can also resize it. Okay, the same syntax you have to follow. Okay, now the last function that we are going to discuss for today is called free function. Okay, now in dynamic memory allocation, what we are doing, we are allotting some space at the execution time, at the runtime of the program. Okay, now suppose you have allotted already some space and you have used that spaces, but some spaces are there which are no longer in use. You are not required these addresses in future. So what you can do, you can freeze up these resources that has already been allocated. Okay, so if you want to freeze up these resources, then you have to call the free function. Okay, so what you have to do, you have to just call the free function and you have to just mention the starting address where from you want to freeze up the memory. Okay, so we are mentioning ptr. Okay, free ptr, we are passing ptr. That means suppose ptr is now pointing to this location, this 1001. So if you are passing free ptr, that means from 1001, whatever be the contiguous location that has been allotted previously by malloc or calloc function, the entire bytes will be freeze up. Okay, so here it is 20 bytes, so entire 20 bytes will be freeze up. Similarly, suppose ptr is now pointing, after reallocating the memory, ptr is now pointing to 1001 and the total span of allocation is 40 bytes. So now if you are calling free ptr, okay, if you are calling the function free and ptr if you are passing, then this from 1000 to 1, the entire 40 bytes will be freeze up. Okay, so this is called free function. So it is a very good practice whenever you are allocating some memory using either malloc function or calloc function with the help of dynamic memory allocation. So after working with this space, it is a very good practice to freeze up those memories so that in future this memory can be used for further purpose. Okay, so my dear students, today I have discussed the 4 different dynamic memory allocating function. Okay, so these functions we are going to use widely in case of linked list. Okay, so I hope that you have understood the concept of this dynamic memory allocation. Why do we need to implement? Okay, so thanks for watching. Please take care. Have a nice day.